All right, so today we're going to be working on solving a system of linear equations using the substitution method. So when solving a system of linear equations by the substitution method, the first step should be isolating a variable in either your top or your bottom equation. So you'll notice in this top equation, y is equal to 2, our equation is already, or our variable is already isolated. Okay, so we kind of got lucky here in that most of the problem's done for us. So after this, step 2, we're going to substitute whatever that variable is equal to, which in this case is 2, into the other equation, okay, for that same variable that you just solved for. So if we said that y is equal to 2 in the top equation, in this bottom equation, we can kind of substitute in a 2 for y. So I'm going to rewrite this as 2 is equal to negative 2x plus 6. And let's freeze for a second, and let's kind of look at our equation now and see if we can solve for one of our two variables. Well, it looks like we only have an x left over. So by substituting in a 2 for that y, we kind of allowed ourselves to solve for x. So that third step here is going to be solved for the other variable. So I'm going to subtract 6 from both sides. I'll get negative 4 is equal to negative 2x. Plus 6 and minus 6 cancel out. I'm going to divide both sides by negative 2. And I have 2 is equal to x. So after you find out what x is, remember a solution to a system of linear equations has to be an ordered pair. So we have to do what's called back solving. So you have to back solve. So I want you to choose one of your first two equations. I'm going to choose this bottom one. I'm going to have y is equal to negative 2. Instead of x, though, I'm going to substitute in a 2. So instead of x, I substitute in a 2 plus 6, okay, into that original equation. And then we're just going to solve. So I have y is equal to negative 4 plus 6. So we know y is equal to 2. So my ordered pair is going to end up being 2, 2. My x value is 2. My y value is 2. And I also want you to notice that did we really need to do this last step? Well, not really in this case, because we kind of already knew what y was equal to because of that top equation. However, in the future, you are going to have to back solve, unless, of course, y isn't equal to, some value. So in this one, we're going to see a situation just like that. So if I have y is equal to 4x minus 5, it's one of my equations, and y is equal to 3x plus 2, the first thing I want to do is isolate a variable. You'll notice that both the top kind of and the bottom equation here, they're both solved for already. They both have a y is equal to some expression. Okay, so in the second step, we're going to substitute kind of whatever that variable is equal to. So I'm going to choose y is equal to 4x minus 5. I'm going to substitute in the 4x minus 5 for y in the bottom equation. I'm going to rewrite. So I'm going to end with 4x minus 5 is equal to 3x plus 2. Okay, and then we have to solve. So let's solve. So I'm going to subtract 3x from both sides. I'm going to get all of my x's on the same side of the equation. So I'm going to have x minus 5 is equal to 2. I'm going to add 5 to both sides. I end up with x is equal to 7. Now we aren't done here. We do need to back solve. So I'm going to take this bottom equation here, which is y is equal to 3x plus 2. And I'm going to substitute in the x is equal to 7. So instead of x, I'm going to write 7. So I have y is equal to 3 times 7 plus 2. So I think this is going to end up as y is equal to 21 plus 2, or y is equal to 23. So after you back solve, we should have enough information to write our solution as an ordered pair. I think in this case, x was 7 and y was 23. So your ordered pair, where these two lines intersect, is 7, 23. In this last one, I want you to notice that we don't actually have any variable that's isolated. We have 2x plus 3y is equal to 4 and x minus 4y is equal to 13. So neither top or bottom equation has one variable by itself on one side of the equation. So we do need to do a little isolation here. So I'm going to choose that bottom equation to isolate one of the variables. I notice that x doesn't have a coefficient, so it would be very easily isolated. So I'm going to take that bottom equation. I'm just going to rewrite it, guys. And then I'm going to kind of solve for x. So I'm going to add 4y to both sides. And on the left side of the equation, I'm going to have x is equal to And on the right side, because the negative 4y and the positive 4y cancel out, on the right side I'm going to have 4y plus 13. Notice as well on the right-hand side of this equation, we have 13 plus 4y. We cannot combine those. Those are not like terms. So I have to literally rewrite them as 4y plus 13 or 13 plus 4y, either one. So also notice now I've got my variable isolated. X is equal to 4y plus 13. So I can move on to step 2, which is substituting that entire 4y plus 13, substituting that into my other equation. So I'm taking my top equation here and I'm rewriting it and I'm substituting in for x. I'm substituting in for x, 4y plus 13. Okay, so let's rewrite. I'm going to have 2 times 4y plus 13. Make sure you put 4y plus 13 in parentheses because we are going to have to distribute that 2 to both the 4y and the 13. It's going to give me 8y plus 26 plus 3y is equal to 4. Let's simplify where we can. So I can do 8y plus 3y. It's 11y. So I got 11y plus 26 is equal to 4. Okay. So at this point, you know, I can kind of just solve this as a two-step equation to solve. So I'm going to subtract 26 from both sides. I end up getting 11y is equal to negative 22. Then I divide both sides by 11, and I find that y is equal to negative 2. So solving all of that gives us one of our variables. We need to do that last step, which is back solving. So I'm going to take one of my original 2 equations here. I'm going to take this bottom one, x minus 4y is equal to 13. I'm going to rewrite. And then I know what y is. So instead of y, I'm going to substitute in a negative 2. So I have x minus 4 instead of y. I'm going to substitute in a negative 2. Okay, and then let's just simplify and solve. So I got x plus 8 is equal to 13. Subtract 8 from both sides. I've got x is equal to 5. So then my final answer to this is 5 comma negative 2. So those were 3 examples on how to use substitution. Substitution will work every single time when trying to solve a system of linear equations, and you will always get an ordered pair as your solution in x comma y.